of the multiple. Right, last one of the multiple choice, and actually it's the last one of the multiple choice, not that you'd know that if you did this in order, but okay. Question 21. A simplified mass spec of an organic compound shown below. Which of the following compounds could not have produced this spectrum? Okay, so look at what we've got. First of all, we've got our molecular ion up here at 74. We've got a 15, that tells you it's got a CH3 group hiving off somewhere, and there's the 59 obviously of the split of the 74. So have a look at the compounds. Well, all of them have got CH3s, so it's got to be down to mass. It's just a whole pile of calculator bashing basically. This is 74, this is 74, this is 73, and that is 74. So this one wouldn't work. Don't know if it's super hard. Question 22, you can see I've brought in data book stuff. We've got a compound. The infrared spectrum of this would not be predicted to have an absorption in the following wavelengths. Okay, so let's just highlight the lot of them. So we've got benzene ring, we've got 29, where's my 29, 6, 2, there we go. Alkane, CH stretch and an alkane. We've got 1730, we've got an aromatic ester, C double bond O, and we've got 11510, that's it, there's our alkyl ether. Okay, right, and then you just got to find it, work out if you've got them. Okay, benzene ring, check. You know, this is a circle in here, so that's going to happen. Okay, so it's not that. Alkane, well, this would be up here. Okay, so it's not that. Aromatic ester, no, I don't have a C double bond O on that one, so nope, that's not going to happen. And just to check, last one, an alkyl ether, here we go, that's an O bonding to a C there on the other side, so not that. Okay, I think that one's alright, you just got to work through it carefully. Question 23. Salbutamol is used to treat asthma. It behaves like the body's natural active compound by triggering a response in the muscles of the airways. Salbutamol is, by definition then, an agonist because it's working with the body's natural response. Straight definitions. Okay, question 24. Sorry, again, there might have been a little bit of a blip there, and that's because my printer started printing stuff out. I hadn't sent it, but it's just above the computer and it's very loud. Right. Question 24. 200 centimetres cubed of water added to 50 centimetres cubed of 2 molar sodium hydroxide. Concentration of diluted sodium hydroxide is what? Right, so start off by working out moles. Moles is concentration times volume. So we have 2 molar and 0.05. So I have 0.1 moles in that. Okay, I'm now going to add in my 200 centimetres cubed of water, which is going to mean that my final concentration, moles over volume, 0.1 divided by my volume is now 250, so 0.25, so my final concentration is 0.4. Okay. Question 25. For solvent extraction from an aqueous solution, the solvent used should be immiscible with water and relatively unreactive. Which of the following would be the most suitable solvent? Kind of expecting you're almost running for this straight away, but just to be absolutely clear, if something's going to be immiscible in water, then we really want to avoid hydrogen bonding for a start, so these have problems, get rid of them. And then we have an aldehyde here, and we've got an ether. Ethers are the best for that. They're just immiscible and unreactive. This would still be maybe a little bit soluble given the size of the alkyl chain. So B. Question 26. Which of the following is not a step in a recrystallization technique? Okay. Right. So first thing you do is dissolve them in the minimum of hot solvent, and then you'd filter, and then you'd cool it. So all these first three are definitely recrystallization. Testing the filtrate to ensure no more precipitate forms, that's not recrystallization. That's one of your steps when you're doing a gravimetric analysis and you're checking to make sure that you've got nothing left of the thing you're trying to precipitate out to measure. So this one is not. Question 27. The melting point of an impure substance was determined to be 111 degrees C to 114. Okay, impure, saying this is impure. After purification, melting point should be. So if I purify the substance, for a start, I should end up with a much narrower range because I have more precision about what I've got there, and it should be top end. Okay, so B. 28. During the technique of heating to constant mass, the purpose of the desiccator is to do what? So the desiccator is basically, this is a straight KU thing, it's stopping the reabsorption of water by creating a dehumidified air. Okay. 29. Using TLC, the components of a sample can be identified by RF values. Which of the following affects the RF value for an individual component? So RF, being absolutely clear on this one, okay, so this is the distance of, what are we saying, spot, whatever the spot is, travelled, divided by the distance of solvent front travel. So basically the maximum point the solvent has got to. Okay, so which of the following affects the RF value for an individual component? The distance moved by the solvent. No, because that will just increase the distance moved by the spot. You know, this is just going to end up as a fraction anyway, so no. The concentration of the sample. That is going to make it easier to see, but it's not going to change where it ends up. The length of the TLC plate, well, this is a fraction. So if the plate was, say, 10 centimetres and the solvent front travelled 9 and the spot travelled, say it was an RF of 0.5, so it would travel 4.5. But if the TLC plate was 20 centimetres, then you would still, the solvent would travel, say 20, but your distance to the spot would be 10, so you'd still end up with 0.5. So it's not going to change the RF because the RF is a fraction, so not that. However, the solvent is what's picking up and moving everything that you're looking at, so change the solvent, change the solubilities, that's going to change where it gets dropped. So definitely solvent used. And 30. Which of the following diagrams shows the apparatus correctly set up for heating under reflux? Okay, so can we get rid of A and B straight away? This is not heating under reflux at all. This is basically a distillation, because you've got something being heated up here and then condensed down into here and dropping out. Okay. C and D, okay, what we have here is the correct setup in terms of where you've got your condenser. So what's happening is you will have vaporization of your whatever compounds you're working with, and then this condenser should be pushing it back down into the reaction chamber. Okay, so it's to do with whether your water in should be top or bottom, and that's just a straight KU point. You should have your coldest water hitting the hottest point of the vapors, so it has to be at the bottom, okay, because then it does its most good to cool it back down. So correct answer on this one is C. And at this point I have now worked every single question from the Advanced Higher Chemistry CFE papers. I really hope that they have been super helpful. That's it.